Okay, everyone. Hi, I'm Yuri, and I'm presenting to you the update from last year's Hierarchical Constant Bandwidth Server. And what is a Hierarchical Constant Bandwidth Server is basically a rework of the RT group schedule. And instead of using the standard mechanism, we want to use deadline servers. Why? Because we are reducing the code to maintain, and also it's almost an effortless implementation for the same feature. This also increases, the real-time soundness. We remove the runtime migration feature, and we avoid the deferrable server issue. So basically, we can use real-time containers in a more sound way for real-time. As an extension for the RT group sched, we can have also better control for runtime allocation. In fact, we can set up runtime budget and period for each CPU instead that for the whole hierarchy. So to use basically only a subset of CPUs in each C group. And this may also allow to use unprivileged FIFO or round robin tasks. So because the system administrator can decide how much bandwidth you can give to the C groups. Finally, it's basically a rework for real-time C groups for C groups VTU. So I present you, I don't know, basic examples where you could use this system. In a factory environment, you have a lot of robots. You want to offload their motion controllers on your local private cloud. And the system is built such that if one of the controllers fails, it won't affect the other controllers. You can think about an autonomous driving car if you want to think about controls that you want to isolate from each other. Or you can think also about the cloud where you have multiple users and you have real-time workloads, and no denial of service can be caused by users. So you can guarantee CPU bandwidth to each of the users of your system. How is it done? So basically, the idea is to interface sched deadline with the C groups to allow bandwidth and reservation and time isolation. So we have basically we use deadline servers, the deadline servers mechanism, but instead of the deferred one, we don't use deferring. And we have one deadline server per CPU, very similar to the fair deadline servers. We have private C group specific run queues to manage the tasks. And so basically the scheduler is invoked recursively. When you pick the deadline server, then you invoke the FIFO scheduler. And this results in a hierarchical scheduling framework, in which you have a first level, which is sched deadline as a root scheduler, and then you have fixed priority. And this is sound for many of the analysis. I put a couple of links here if you're interested. This is one of the, graphical description. This is just for one CPU, but you can imagine that you have your global run queue where you have two different deadline servers which manage two local run queues. So tasks in the first local run queue can only run when the first deadline server is picked for execution. And so it's for the second deadline server. Given that we have a hierarchy of C groups in hierarchical constant bandwidth server, we basically flatten the hierarchy, and there is this concept of live C group, which is a C group that is either a leaf, or all its children have zero runtime, and only live C groups are allowed to execute workloads. Instead, non-live C groups are used to partition the resources, because we have the admission test that children C groups, their total bandwidth must not be above their parent. So in this sense, we are splitting the bandwidth across the hierarchy. And this flattening allows to pre-compute statically all the times that each deadline server can use, and we don't have to cross the hierarchy to compute how much bandwidth you have to give from the top level to the bottom. The root C group is exempt from runtime enforcement and is only used for partitioning the bandwidth, and it uses the standard, tasks in the root C group will use the standard FIFO behavior. And an issue that may arise is that maybe since we are using deadline servers, which use scheddeadline and so are higher priority, there may be some priority inversion of tasks inside C groups compared to tasks in the root. And we have to figure if it's an issue. Okay, how is it implemented? So special scheduling entities that describe each virtual CPU of a C group. And as I said, we have deadline servers that are used without the deferred mechanism by setting the DL defer flag to 0. And I hope that, in the documentation, it says that it should do what it says, but I'm asking.
It should.
It should. Okay. Okay.
If it doesn't, report it.
And the modification does that each server keeps track of its served run queue, which is the private local run queue for HCBS, and for FAIR and SCHEDX servers, they reference instead the global run queue. So when the peak task is invoked, it invokes the global run queue, or it on the global run queue. And yeah, so basically, as I said, when the HCBS is selected for execution, it picks the highest priority task in its local run queue by simply invoking the RT class scheduler on it, or a small modification, because you of course have to account a little differences. The C group data structure is also modified because you have to take into account a deadline entity for each virtual CPU, and these deadline entities are bound to the physical CPUs. And also you need the same number of local, a number of local run queues, one for each physical CPU, because these are bound to the deadline entity. So there is like this run queue duplication every time you create one of these C groups. The real-time tasks are kept only in the C group run queues and not on the global. So currently, I've been updating it since last year. So the latest request for comments that I've sent is based on Linux 6.18, but I've tried to keep up. So the latest on Linux 7. And I have to thank who reviewed the patch set because it's a great help in shaping it. And so, yeah, basically, the work that we have passes most of the Linux test project tests. And I developed a specific test suite for all the corner cases, all the stress tests for affinities, switches, and also to verify that the time reservation and isolation properties are respected, also by using RTApp, but there are still some bugs that needs to be fixed. So from last year, of course, I've been, yeah.
Sorry, if you don't mind a question in the middle, I just had a question about the C group testing. I was wondering how do you generate workloads? I was playing around with benchmarks to generate random trees of C groups. Then I was having trouble defining the oracle that would actually give us semantics to the random tree of C groups to define what should happen.
So basically, as I said, you flatten the C group hierarchy. So the C group tree doesn't matter anymore. If you allocate a certain amount of bandwidth to a leaf C group, that's it. You don't care about the parent. The parent is there only to say if the parent has 20% bandwidth, the children cannot have more than that. But it's just for splitting. So you flatten the hierarchy. And the tests, how do we generate the tests? So basically, in real time, you generate a task set. It's kind of the inverse, in the sense that you generate your task set, which is periodic tasks that you can emulate with RTApp. and then you derive which interface, which C group setup should respect these the requirements, the bandwidth requirements of these tasks. And then you execute your workload, your synthetic workload, and see if you have effectively respected all the deadlines, let's say.
This is based on the real-time data actually describe how this should be working, and then you generate a task set that actually proves, and then you run the thing, and you actually verify that it actually it's meeting the deadline.
Well, thanks.
Yeah. But also, I mean, the other features like time isolation, you test it by, I don't know, running competing workload on Skedadder or stuff, and see if you're limited on your budget or if you're effectively getting all the budget that you requested. So there is both worlds. So I was saying I've been rebasing it, and the migration code has been reworked since last year. And since I've mentioned that we want to support the per virtual CPU settings, there is this multi-CPU feature which has been reworked. Also, the interface as suggested by last year, and also I have also added partial documentation what is going on. So for the future, I hope to fix issues that arise today, and I'll try to send you a new request for comments very soon, hopefully with more stress tests. And yeah, I will talk about some of the open issues. So yeah, as I mentioned before, we have to check that the DL-defer flag works as expected, because of course the non-deferred deadline servers are not used yet in the kernel. And I think that there is some place where there is no check for this. I can give you some details if you want, but yeah, we will send bug reports. But as we have said, that's the meaning of the flag. And for task migration, I want to bring up this because also it may be of interest for those guys for Andrea or SCEDEX guys that are working also on hierarchical stuff. And so basically, what is the issue is that when you have to ensure that when a server is picked for execution, you want the highest priority task to be scheduled. And I have a very simple example here. So if you have a 2 CPU C group with 10 milliseconds every 100 of runtime, and we have only one task, the situation that arises is more or less this. So basically, we first start executing on the first CPU, and then we push the task on the second, and the DL server wakes up and executes, no problem. We can try to push at the 20 millisecond mark, but there is no available deadline server because they are all throttled, they have consumed their budget. And so what happens is that at the 100 mark, the server gets replenished, but there's no tasks in its run queue, and so it's stopped. And then at the 110 mark, the CPU1 server gets replenished as is task, which is the task that has not been migrated. So it executes and then it pushes. And of course, this is an issue. And this issue arises because, generally when a scheduler, when you work on a scheduler, you think that you always have all the CPU available for yourself. But instead here, you should get like some sort of notification at time 100 that you have been given some bandwidth.
Can you try to pull?
Yes, exactly. I mean, I have two ideas. You can either try to pull when it's rescheduled, or you try to push to the earliest waking deadline server. So, I mean, I don't know if which work here best.
the push, maybe it's more difficult because then you don't know where to, I mean, in this case, yes, but if you have like n CPUs.
Yes, you have to check all the CPUs and get
And
the
then which
earliest.
one is the first one to,
Yes.
so probably the second one is easier because the first one that it's replenished, it tries to see if there is anything to be pulled in it.
Yes. Yeah, the only thing is that maybe it has to check all the run queues because I don't know. I mean, you have to also respect the fact that the highest priority task has to be there.
So won't they both try and start the server at 0, and then one will find a task and the other will find there's nothing to do and go back to sleep?
Yes.
Right.
I mean, yeah. No, the deadline server, sorry, it started when you enqueue the task on the run queue. So the CPU 1 is idle at time 0, and then when you do the push, you start it.
Okay.
So you give the bandwidth there. Yeah. But yeah, so basically, I mean, the solution here probably okay, thank you. But I also wanted to highlight in general that to do this kind of scheduling where you do the hierarchical stuff, you have to take into account these situations. Otherwise, you have like in some sort of inversions. And okay, why the multi-CPU cgroups? Because if we think about a big machine with 128 CPUs, with the standard feature, you would reserve 10% of the bandwidth, let's say, for all the machine cores, and maybe it doesn't make that much sense. And so the idea of the multi-CPU interface is to request bandwidth on a subset. And I mean, originally it was just on runtime. I've updated it also to include the period. And I mean, the questions here are, does it make sense to do this, let's say, select a subset of CPUs? And do we allow to vary runtime and period independently for all the CPUs that are active or not? And there is also the CPU set controller, which we have to understand how to integrate it.
Yeah, so since you limit it to V2, cgroups V2 only, the hierarchy of CPU sets and the RT thing will overlap. It will be the same hierarchy. So you can use the CPU set partition information directly. For non-V2, this doesn't work, and that's a royal pain in the ass. But since we're limited to V2 only, you can do this. You probably should do. But
the problem is that how do we integrate it? Because, I mean, also for research purposes, I'd say that it's interesting to set different runtime on each virtual CPUs.
Right.
But
so the root domain of a particular CPU should already reflect the partition, but you can also, and I have some code for that, cast the CSS or CCS pointer to another controller. It's a bit involved. I have some code. I'll try and reply to your next posting. But then you can get the controller, the CPU set controller from the SCAD controller, and you can use the affinity masks that are set there. It's a bit tricky, but it's doable.
I think the context here, if I understand well, is that you would like to have like a subset of CPUs, and then also a way to specify different bandwidth in that affinity mask.
Yeah, and this allows setting bandwidth outside of that group.
Oh, okay.
Because you can't go there anyway.
Yeah.
okay. What else is missing? Okay, yeah, I've reworked the multi-CPU interface, and let's see if it makes sense. So basically, last year there was another file, and instead this time there is a single value for runtime and period, which is the standard, or you can supply a list of pairs value and CPU list where value can be either runtime or period, and the others will be set to 0 by default.
Yeah, so are there other multi-value files in CPU sets? Because I don't object to this, but Tejan might have an opinion. Yeah, I need to, you know? No. I need to check, but.
Okay. Okay. Then yes, for the other issues, there is the CPU hot plug, which I mean, do we add support for this, or we just say that is disabled by default?
I think we'll have to.
Yeah.
You can disallow hot plug if it violates your schedulability or something, but this might upset people. And you have to allow suspend, irrespective of, yeah. It has a special flag. Suspend your real-time workload.
What happens with deadline task now if you suspend? What happens for deadline tasks?
It gets frozen right along with all the other tasks.
Then when it panics when you open up your laptop. The deadline task.
Depending on what clock it uses, it will either shit itself or just continue.
But yes, we allow that, of course. But yeah, I mean, you need to allow that, and you don't want to do that, of course, if you're running something you care about. That's different thing. And also we allow a hot plug until you meet the admission control. Let's say you can restrict bandwidth until you meet the requirement of the task that is running inside the thing. So yeah.
Yeah. Okay. So
Maybe
we
just kill, just like if you do a hot plug, just kill any task that loses its won't fit in the scheduling algorithm.
No, you don't know because FIFO and RR are a piece of shit. So you can disallow the hot plug.
Yeah.
That's the only option that you have. And then if the administrator really wants to take the CPU out, it will have to.
Well, the reason why I'm wondering about that is because wasn't one of the things to allow like unprivileged users to set, can unprivileged users set this up?
I mean, this was never checked, but we could, yes. I mean,
Yes,
does
so
it make
unprivileged
sense?
user
But they
sets up-
cannot set up the bandwidth constraints. They are constrained to the bandwidth that is set by the administrator.
Okay,
So the administrator sets up a C group with a bandwidth limit and then says this C group can run unprivileged.
and if the hot plug violates that, then it won't let you do the hot plug. That's the administrator's fault.
Okay. And yeah, another question that we had is if we have, I mean, if it makes sense to integrate it with schedule for frequency scaling and stuff.
It's not integrated already. I mean, we have the integration.
No, I mean, what I mean by integration is that you would have to rescale maybe to take into account frequency scaling for CPU capacity for heterogeneous systems. This is something that we have to work on.
Yeah, the accounting, the deadline entities accounting is already scaled by frequency and capacity.
Right, and for
DL servers was removed.
For DL server, not yet, but I guess can have a flag to say, okay, for this type of servers, maybe we want, because yes, DL server doesn't, I don't think we want that. And they do, so maybe it just, I guess
But even in this case, you will have an RT test running your DL server. So should we use the RT?
I guess, depends on what the theory says. I mean, if we have like a theory that uses is aware of the scaling and then we need to do that too.
Yeah, so theory says that we have no bandwidth constraints on FIFO and round robin, so we should assume max. But
No, but I mean, you can also do your analysis assuming the constraint. It's not a problem.
But the kernel doesn't know, right?
No, the kernel
FIFO tasks.
I know, but I mean, if you want to do it, just shut off the deadline servers and.
So we used to set max frequency when we run FIFO, We also had some code that computes the average and sets that. I forgot what we currently do.
The average is just used to see how many compute capacity we still to the CFS task.
Okay.
And we have another system, knobs, where we can limit not to the max, but a lower PP than the max frequency, because sometimes your RT task doesn't need the various frequency.
Yeah, but anyway, I'm not sure if we want to do it or not, but if you want to do it, I mean, I think the only thing that is needed is kind of a flag on the DL server to say scale it. Because I mean, the scaling itself is enabled on normal like one-to-one deadline entities. So, and those are entities as well.
Yeah, the main problem, if it's a point, that scale detail, if we have, when we are looking for the OPP, if we have a RT task runnable, we move to the highest OPP. And we don't try to compute any other kind of.
But for deadline, we do, because for
Yes.
deadline, we have bandwidth information available.
And the better information is also present here. It's the better information of the group of tasks.
Yeah, but in this case, we will have both a DL server where we try to use the bandwidth and RT task. The RT task will still be visible in the schedule. So then either we use one or the other, but not both.
I would say you want to use the deadline one, so it's the group thing. But
You cannot exceed anyway the.
So yeah, so the deadline actually gives you information.
Yeah.
Whereas the FIFO, you must assume worst case. So yeah.
Yeah, but the deadline bandwidth, I mean, still gives you an upper bound on how much you will consume. So.
But yeah.
What about the soft
real time?
Yeah, the extension, how is it called, the flag? That's
in principle, can be used also in this case.
For now, it's not.
But I guess I would say we want to try to implement it for single entities and maybe then extend it.
The reclaim flag.
Reclaim, yes.
So that actually makes the question much more tough, because if you have a flag reclaim, then
in that case, what to do? Yes.
Then maybe you should go to max, as it says.
Or maybe not, because you're essentially executing outside of what you requested. So.
But the reclaim is not guaranteed; it's opportunistic. So.
Okay, so I guess that, I mean, for the main issues, since we have some time, I mean, plenty, I guess.
Yeah.
I mean, discussion extras, it's just one thing, to be fair. And it's an issue that I noticed a while ago, but I mean, so it's basically more related to the FAIR servers, and nowadays also the EXT servers. So, I mean, I've noticed that, there is the sched_DRT runtime and period files that decide how the bandwidth for the deadline tasks is reserved, and in the past was used to do the RT throttling, but nowadays no more. And I mean, as I'm saying here, the FIFO tasks are throttled by FAIR servers, and the bandwidth of deadline tasks is instead limited by this amount. And what happens is that, so basically there is a discrepancy because you can change the settings of the deadline, the FAIR servers, regardless of the settings of the sched_DRT runtime and period. And
so the global runtime and period are a cap on admission control. I think that's all they are at the moment.
Yes. But I mean, okay, yes, but what I mean by discrepancy is that by default, what happens is that the max bandwidth for deadline tasks is 0.95 for this ratio, runtime period of these settings. And then you have to take off 5% because of FAIR servers and another 5% because of EXT servers. And so if you try to allocate deadline tasks, you can use at most 85% of the total bandwidth.
Yeah, so I think we should raise the default to 1. And Andrea was gonna fix the double allocation thing by disabling whichever one is not in use, except for the mixed model where you have both.
Okay, so I mean, the idea is to change it to just limit the deadline bandwidth.
Yeah, I think it's just a setting for global admission control, and it's still usable to disable admission control as well, isn't it?
Yeah.
Yeah.
Yeah, I guess, well, that's the same, but I guess it's part of the interface discussion that we had yesterday. Then maybe, I don't know if we want to keep it, or it's kind of confusing, because I mean, it used to disable the profiling thing, nowadays doesn't anymore. So maybe people can expect it to do that. And then you don't have an actual non-debug interface to be able to disable the fair server next server if you want to. So, but that's I think what you said yesterday, that you would like to have this implemented, then we have the discussion on what the interface, the whole interface looks like. So
Right.
yeah, I think that the answer, at least in this case, is that we want to have 100%, so 1, and then remove the 5% of with fair and X, and then have it the rest to deadline. So in this case, we will have 90%.
But won't these like break the? I mean, maybe there are some old scripts that, I don't know, changed the behavior of the RT throttling, and now it doesn't work like that anymore.
Yeah. We had to break something. Same with the new controller.
I mean, another idea that I could tell is to not control the fair servers individually, but with the same setting, all this shared.
But that gets us into trouble with Ext.
Yeah.
You might want to independently control fair and extended deadline service. They are separate entities. Having a single control for them is a bit weird.
Okay. Yeah, I mean, that's it, I guess. So to conclude, I hope we are getting close to a more stable patch set, and yeah, we have discussed everything. I hopefully we'll fix the new stuff soon. And okay, thanks for your attention. And if you have any other questions.
It's not related to this, but since we discussed yesterday and still we have like 5 minutes, we can discuss. So you mentioned that the current test that we do for the mission control, this is the kind of thing without considering groups. It's not ideal. I mean, it's something that we do because we have to do something. It makes sense for single processor, but for multi-processor, I mean, usually I think most of the people that for experiments for using it in disable the thing and do the admission to the proper one in your space. But you suggested there might be an alternative.
Yeah, I mean there is like a test in literature which is also simple to compute in that works for global scheduling of earliest deadline first.
Yeah, and then there was the semi-partition stuff.
Or there is.
Yes.
The problem is that the test for global scheduling is something that it becomes very, very basically makes you only use one core override, no matter if you have 100 cores.
Depends on.
Very close to that, basically.
I mean,
one core of utilization.
It's based on the task which has the highest utilization.
Yeah, and that's
so I mean,
it's very pessimistic.
If the utilization is high, yes, but if it's not that bad. If it's around 50%, let's say, of bandwidth, it will be half of the number of cores, which, considering the pessimism of global scheduling, is standard, let's say.
The question is, do we bother changing it or not?
I don't know.
Yeah.
But then if you, the test is for global. Because if you then switch to a partition setup,
I mean, if we switch to a partition setup, but this requires changing also the deadline infrastructure, which means that the scheduler has to pin a task on a CPU basically, and
Yeah.
with the first
to use
feed.
affinity masks, you have to disable the test, right? Anyway, you want to touch any affinity mask, you disable test. Or if you use different scheduling domains, different rules scheduling domains, then the test will actually fall back into full utilization. Because on a single CPU, you'll be able to use the full CPU. So
And you can cut up patients into smaller bits.
So maybe practically, maybe we could say, let's try to do this, and then
Which one, sorry?
not the hierarchical stuff. I mean, let's try
Okay.
to work on this, and then maybe we move to the same partition, and then at that point, maybe we change also the emission control. Okay. I mean, yeah. Okay.
Okay.
Thank you.
Thank you. I've left here some resources if you're interested.
Yep.